Alrighty, so this is a question about electrolysis of aqueous copper sulfate. Okay, aqueous copper sulfate. So this is our copper sulfate right here, CuSO4, aqueous. So let's first try to separate this into its anions and cations. Right, so copper, obviously this becomes Cu, copper ion, it's a metal, so it should be positive. You may remember it's a 2 positive, 2 plus. And SO4, this one you should remember. SO4 is always 2 minus, right? So copper sulfate is Cu 2 plus and sulfate is SO4 2 minus. Now the tricky thing here is to notice the term aqueous, right? The term aqueous. The term aqueous means that it has H2O, right? It has water in it, and water is also can also be broken up into two different ions. So we have the H plus and the OH minus ions. So in total here, we're looking at two different cations, right? Two different cations. So the cations I put as yellow. So cations are Cu2 plus and H plus, and the anions are SO4 2 minus and OH minus. Now, once we have this, the next step is to understand which one will go towards the electrodes, the cathodes and the anodes, and which one will stay as an ion. For the cations, the positive ions, cations, the more reactive will stay as ions. But for anions, the less reactive will stay as an ion. Stay as ions. The way I like to remember it is cations, they're the positive ions. That's why it's the more reactive ones that stay as an ion. Whereas anions, because they're the negative ions, that's the less reactive ones that will stay as an ion. Right, so this is one thing that you have to remember about electrolysis when you have multiple cations, more than one cations and more than one anions. The next thing you will have to remember is this chart. So this chart I've already given you in your slides, which tells us roughly which one is less reactive and which one is more reactive. Now for your anions, your negative ions, obviously the most reactive ones would be all the most reactive nonmetals, right? The most reactive nonmetals, those are in your group 7. And similarly for the cations, the most reactive ones would be the group 1 and the group 2, right? In the middle, those are the two ions that make up water, H plus and OH minus, right? If it helps you to remember, think of it like pH. Again, water is also in the middle, and the ions of water is also in the middle. And on the less reactive side would be all your other nonmetals and other metals for anions and cations respectively. Okay, so the question is asking what will be formed in the electrodes. Yeah, what will be what's the products? So we're asking what's going to stay as the ion. What's not going to stay as the ion? What's going to be created? So for cations, we want the more reactive one will stay as an ion. Right, so and let's look at your cations. The more reactive ones would be group 1, group 2. We don't have any of that. Copper is not group 1, group 2. Hydrogen is not group 1, group 2. Next is hydrogen. And the less reactive one would be the other metals. So hydrogen will stay as an ion. So it's not going to be formed. So copper will be formed as a cation. And the anion, the less reactive ones, will stay as an ion. So let's look back. Group 7, we don't have any group 7. We only have OH minus and SO4 minus. So the less reactive one in this case is SO4 minus because that's non-metal. So the less reactive one will stay as an ion. So we won't have any SO4, right? SO4 will stay as an ion. So the two that will actually go to the electrodes, the one that will actually form, is copper and OH minus. So OH minus, copper ion will just form copper metal at the electrode, and OH minus ions will create water and oxygen. And the only one with that is with that option is C. Okay, hopefully that's clear. It's a bit long, and this is a bit of a harder question, but let me know if it's unclear.